Okay, in this video, we're going to talk about torque. So torque is basically a rotational strength. Okay? It's not a force, and it's calculated by the torque. Okay? It has a symbol like this. Okay? Just, just it looks like T, but it's not a T. Something like that. Okay? And it's calculated by force times the radius. Okay? Now, force times the radius. So, okay, let me show you a YouTube video who explained this.
Now, torque is everywhere. Anytime something is rotating, there's torque. So, notice, paper towel holder. I pull the paper towel, the roll rotates. I'm applying a force here, and it is rotating around this axle. Here, there's a knob on the sink. If I push it, it's like a lever. If I push it, it will rotate around the little axle that's inside there. If I push it close to the end, it's a little harder to move than if I push it far out. We'll talk about why that is in a second. And then finally, we have a lever like a ratchet. If I put this in and try and tighten or loosen a bolt, tightening it or loosening it, and I can't push any harder, something that I can do actually to make it easier is put a section of pipe on. So now I've extended the radius by giving myself a longer lever arm. Then I grab down here and I can easily undo the bolt. The last thing is even opening a door or a cupboard. You're applying a torque because it's rotating around the hinges, and as I pull it open, I'm applying a torque all the way out here. If I try to open it here, it's actually really hard for the same reason. I don't have much leverage. So in all these things, here's the paper towels. I applied a force to the towel, and here's the radius, the distance which I away from the center, or you can define it as the distance from the center or axis of rotation to the point where the force is applied. Here's the wrench with the extended handle. I'm applying a force, pulling it with my hand, and the radius is this long. And the cabinet door. It pivots like that, so I push on the knob to close it, and this is the radius, the distance from the axis of rotation to where the force is applied. There are two places on your car where this really occurs. You have torque applied to the lever arm of your mousetrap by the spring, so it wants to go in an arc and snap. Now where is it applied? Is it applied up here? No. It is applied here. Why? Because that's where the spring...
Okay, now let's stop. Okay, now, yep. So let's talk about it. Okay, so let's just do it simply. So torque is force times radius. The units for force is newtons. The unit for radius, well, it's basically the distance, the perpendicular distance from the point where the force acting and the center of the axis, center of the rotation. Okay, so we call it radius, but yeah, it's measured in meters. So the torque has a Newton, has a unit Newton meter, okay? Because force times distance. Now, so let's do 8 here. Okay, say if we have a wrench. So we have a wrench. Okay. Now and I apply a force. Okay. Say the force is going to be 10 newtons, and the distance of the wrench to the bolt is say 0.5 well, let's make it smaller, 0.1 meters. Okay. So the torque in this case will be force times the radius. Okay. Now, and the force is 10 times 0.1, which is 1 Newton meter. Okay. Just remember, torque only happens in rotation. Okay. It's a rotational strength. Okay. Now, compare with a bigger wrench. Okay. With a bigger wrench, say this is 0.2 meters, and I'm applying same force, 10 newtons on this. Okay. Now, if I do the calculations, my torque will be 5 times R, which is 10 times 0.2, which is 2 Newton meters. Okay. Yeah, the idea is the longer the distance, the longer the radius, okay, the bigger the torque is. So that's basically all you need to know for year 12 now. Okay. So we just the idea we're going to the idea I have to introduce you torque is because we're going to study DC motors, okay, electrical motors, and when we study motors, because the motors rotates, okay, and you just need to know the basics about the torque, which is force times the radius.